children, welcome to Form 4 Chemistry. Today we are going to learn the first term topic, the atomic structure. This is the third lesson from the student book and it is from page number 24 to 28, and you can also refer the specification, that is from 1.14 to 1.17. And here is the content for you children. We are going to learn the following topics: structure of an atom and atomic number and mass number, isotopes and the relative atomic mass. And here are the learning objectives. You will be able to know what is meant by the terms atom and molecule, and to know the structure of an atom in terms of the positions, relative masses and charges of subatomic particles, and to know what is meant by the terms atomic number, mass number, isotopes and relative atomic mass. And you will be able to calculate the relative atomic mass of an element from isotopic abundances. Children, have you ever wondered how small is an atom? Right? Okay. Here in this slide I am going to show you how small an atom is. So to define, an atom is smallest piece of an element. Okay? How small it is? Let's see. Look at this copper wire, very thin copper wire. Look at that tip, right? What I have rounded it off. Just take a small and tiny piece of tip of that, and if you magnify this tip, this small piece, right, it looks in this way, right? Yeah, that is the copper wire. And inside this copper wire, all these circular substances, right, these are what you call atoms, right? All these are copper atoms, right? Okay, how many atoms you think in this copper wire are? Yeah, there are plenty, many, thousands and thousands of copper atoms are there, right? And here again I have highlighted and magnified one particular atom, right? A single atom. And then here you can see so many terms like protons, neutrons, electrons, right? So about this structure of an atom we are going to learn in the other slides, right? So now you know the definition of an atom. It is the smallest piece of an element, right? Let's look at different atoms what we come across in the periodic table. So this is a hydrogen atom, very small, tiny atom. And here is the carbon atom. And here is the nitrogen atom. And here is the oxygen atom. So you already know about these elements: hydrogen, carbon, nitrogen, oxygen, and there are other elements. In the periodic table we have more than 100 elements, right? All these elements have the atoms. They are made up of atoms, right? Okay, now have you ever thought about what is a molecule? Like how many atoms are in a molecule, right? A molecule is an aggregate of two or more atoms in a definite arrangement held together by chemical bonds. Okay children, once again, a molecule is an aggregate of two or more atoms in a definite arrangement held together by chemical bonds. So that means it's a combination of two or more atoms. So that's what you call a molecule, right? Right. So we can, what are the molecules you have already know? Children, name some molecules. Okay, let's look at these molecules. This is hydrogen molecule and water molecule. See, in water molecule we have one oxygen and two hydrogen atoms, right? And look at this ammonia molecule. In this ammonia molecule, you have one nitrogen and 3 hydrogen atoms. And that is last one is methane molecule. Here you have one carbon and 3 hydrogen atoms, right? So all these molecules are made of more than 2 or more atoms. Okay children, have you understood? Right. Children, here is the history of the atom. In year 1913, Niels Bohr, the famous physicist, has refined the theory of the structure of the atom, right? According to him, the electrons were revolving in their own orbits around the nucleus, right? Like you know how the solar system works, right? How all the other planets are orbiting the sun, like that. In an atom, the electrons are revolving around the nucleus. Nucleus means the substance or the central part of an atom, right? And with each orbit only able to contain a set number of electrons, right? To see how these electrons are revolving or moving in their own orbits, right? You will have a better look in the next slide, right? Right. Look at this atom. If you cut a piece of an atom, right, how does it look from inside? Look at the central piece, that means a substance that is placed in the center, that's what you call nucleus, very, very small, isn't it? And you can see when you cut this atom, like it's a cut figure of an atom, right, image of an atom. So here you can see the electron orbits around the nucleus, right? Okay, in a simplistic model, electrons float around the nucleus in orbits that are sometimes called shells. So these electron orbits are generally called shells. Here, okay, now can you tell me how many shells are here in this atom? Yes, children, there are 2 shells, that means 2 orbits, right? Okay, so this tiny part in the center, that's what you call nucleus. Okay children? So this is how the electrons revolve around the nucleus, children. Okay? They revolve around the nucleus in their own orbits. See, all are not rotating in the same direction or in the same way, isn't it? However they like, they are moving about. There is no particular direction or anything. So some are rotating in the clockwise and some are rotating in anti-clockwise. You all can see here, right? Right. So these are the electrons in orbits. Understood children? Yes. Now let's come back to the structure of the atom. Look at this shell, isn't it? It's a circular ring. So what do you call this? It's a shell. And inside, what do we see in an atom? Inside, in the center, we see some particles. It is called nucleus, right? So there are some positive particles and there are some which are denoted with letter N. So what are these positive particles are called? Okay, now this is the shell, right? And the particles that have positive charge are called protons. What do we call them? Protons, right? The particles that are denoted with letter N are called neutrons. What do you call them? Neutrons. They don't have any charge. Did you notice that? See, the positively charged particles we have put plus, but these particles that are denoted with N do not have any charge at all, right? Okay, they are called neutrons. And now this is the shell, right? Now you can ask me, where are the electrons? Where are the electrons? Yes, they are revolving in their own orbits in the shell, right? Okay, look here. So these are the electrons, right? And these electrons possess negative charge. Did you see that? There is minus in there, right? Yeah, these are electrons. Okay, children. So now what can you say? Electrons in their own orbits, right? These orbits are called shells. And inside the nucleus only we find these positively charged particles, which we call them protons, right? And the no charged particles are called neutrons. So these protons and neutrons are both in nucleus, isn't it? Okay, children? Yes. Right. Let's have more, okay, about the structure of atoms. Right. Atoms consist of a number of fundamental particles. They are called subatomic particles. The most important are, now what did we see in the previous slide, children? Yes, right? So there are protons, neutrons in the nucleus, and electrons are orbiting in their own shells, right? Okay. So the proton, if you want to measure its mass is 1. We don't have to keep any units. Just remember, if we say the mass of the proton is 1 compared to proton, neutron also has 1 as the mass. But how tiny is electron? Can you believe? It's a tiny, almost we can say it is a nothing. So in the space, when we say that there is nothing, what do we say? There are these subatomic particles, especially the electrons, isn't it? Because their mass is very, very, very small, very low. How much is that? It's the mass of, if you compare the mass of proton, right? It is 1 over 1836. That means 1836th part of the mass of proton. Understood? Means very small, smaller than proton. Okay? Okay. What is the charge of proton? We already have seen in the previous slide. What is the charge? It is +1. And what is the charge of neutron? It is 0, because neutron did not possess any charge. Next, what is the charge of electron? Yes, it is -1 or minus, you can say. Okay, children, have you understood? Now, let's compare the atom and the nucleus. You remember in the previous slide, I have shown you the nucleus where we have cut the piece of an atom, a part of an atom. In that slide, the nucleus was very small in the central part of the atom, right? Now, you must have thought about how small is the nucleus compared to atom, right? Okay. This is how small the nucleus is, right? Okay. Let's imagine or let's think that a huge, fully grown adult elephant as atom. Okay? An elephant as an atom. Then look at this. What is it? Yes, it is an ant. Tiny creature, isn't it? Very small, tiny creature. Ant. What is it? Yes, that is nucleus, right? So now you know in comparison what is the size of the nucleus compared to atom, right? Right, that is the nucleus. Now you put both of them side by side or just in front of each other. How do they appear? Can you see this here? I have circled the ant because I thought you might not be able to see this, right? So look at the elephant and the ant. Even ant is, even here it is bit bigger, but ant is actually we won't be able to see in front of the elephant. Can you see with the size, right? So now you see this is the atom, elephant is the atom, and the ant is the nucleus. That small is the nucleus. Understood? Okay, children. See, in that smallest nucleus, much smaller subatomic particles are embedded. Okay, can you believe? That means you can imagine the size of the subatomic particles, how small they are, because those particles are inside this nucleus, Okay, right. Now, neutral atom or maintaining neutrality. Okay, an atom can be neutral, right, when the number of protons are equal to number of electrons. Look at this. Most atoms are electrically neutral, meaning that they have an equal number of protons and electrons. Okay, see, look here in this atom, right, there are 3 protons, and outside in their shells, what are these? These are the electrons. There are 3 electrons. We don't have to worry about neutrons, because we should think about the neutrons also, but here when we are talking about the neutrality, we have to consider only protons and electrons. See, are they equal? Yes, number of protons are equal to number of electrons. Then only this atom is stable, or this atom is neutral. It doesn't have any negative or overall negative or positive charge, but it is overall. Atom is neutral, right? So the most atoms are electrically neutral because the number of protons are equal to the number of electrons. So this is the lithium atom. If you want, you can check the periodic table. What is its atomic number, or what is the number it has, right? So lithium atom in the ground state, right, it is electrically neutral. It has 3 protons in the nucleus and 3 electrons in orbit. Okay, children, have you understood? Yes. Right. Now, let's know about mass number and atomic number, right? If you all see this periodic table, you can wonder about what are these alphabets are mentioned, and then there are numbers, right? There are 2 types of numbers on the letter, right? Actually, you have seen this periodic table in the form in the previous classes, form 3, form 2, right? It's not a new thing for you, right? And you know what is mass number and atomic number. Even then, let's learn, right? So, atomic number is what? Number of protons in the nucleus of an atom. Okay? Number of, once again repeat, number of protons in the nucleus of an atom. That is what you call atomic number. Generally in the periodic table, these elements are arranged in respective of proton number, or number of protons in their nucleus, right? Okay, so that's what we call atomic number. So what is mass number? Mass number is sum of the protons and neutrons in the nucleus. Children, once again, see, where do you find these protons and neutrons in an atom? Inside the nucleus. Yes, inside the nucleus. So this nucleus, in this nucleus, these both subatomic particles, when you combine both of them, that would be its mass number. That's why sometimes we call it a nucleon number also, but generally we use only the mass number. Once again, children, atomic number is only the number of protons in the nucleus of an atom, right? And mass number means sum of the protons and neutrons in the nucleus. See, here you are not dealing anywhere, okay, with the electrons, only protons and neutrons. Okay, right. Now look at this sodium atom. Okay, so how many protons it has? Look at this. How many protons? It has 11 protons. So what is its atomic number? Its atomic number is 11. Okay, how many protons? Okay, now let's say that. What is its mass number? Its mass number is 23. Right. Mass number means what? Number of protons and number of neutrons. Okay, now how do you find number of protons? Okay, number of protons you already know, there are 11. Now how do you find how many number of neutrons are there? Yes, You have to subtract the number of protons from 23. Yes, very good children. Right? Okay. Now always remember, if any element or any atom whose proton number or atomic number is 11, means what is that element? It is always sodium. Okay. So these always go together. Anything with 11 protons must be sodium. So no doubt in that. Any element or anything which has 11 protons, it must be sodium. Okay, let's find the number of neutrons, right? See, there will be how many neutrons? You already calculated, right? Yes, I know. There will be 12 neutrons in the nucleus, because 23 minus 11 equals 12. Okay, children? Right? Okay. So here is an exercise for you. You just have to complete the table with the suitable protons and number of neutrons, electrons, and the respective atomic number, mass number, and the symbol of the atom. Okay, children? Just try, right? It's easy. Children, there is something new that you are going to learn. That is isotopes. Have you heard about this term before? No? Okay. What are isotopes? Isotopes are the atoms, right? The same atomic number they have, but their mass number is different. That means there could be, now for example, in the previous slide we have seen sodium, right? What is the atomic number of sodium? 11. Okay. What is its mass number? Yes, 23. This is the sodium atom. Like that, if there is another sodium atom with the same atomic number, that means number 11, but the mass number is 25 or 24, right? So like that, there are different atoms of the same element, right? Sodium, 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 or carbon, 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 right? So same atoms, right? But with the same proton number or atomic number, but the different mass number. So such atoms are called isotopes. What do we call them? Isotopes. How do you define? Atoms with the same atomic number but different mass number. Or you can say the same number of protons, because number of protons are what you call atomic number, but different numbers of neutrons. Okay? So these are what you call isotopes. There are some examples. See, look at this hydrogen, in how many ways it can exist. How many isotopes it can have. Look at this. H1, 1. That means number of protons are 1, but there are no number of neutrons. So its mass also 1. Then there is a number of protons 1, but the neutrons also 1. That is H12, right? And there is another isotope, that is H13, in which the number of protons are the same. Hydrogen has the same number of protons, that is only 1 proton it has. But the number of neutrons are 2. That's why its mass is 3. Another example we'll see. So these are hydrogen isotopes and these are the carbon isotopes. So how many isotopes it has? The carbon. See, there are 3 isotopes. C612, C613 and C614. Always remember, the mass number changes because of the number of neutrons. Understood? Not because of the protons, because protons are always same. See this? Always number of protons are 6, 6, 6. But why this is becoming 13 and 14? Because here the number of neutrons are 6. That's why mass number is 6 plus 6, 12. But in C613, number of neutrons are 7. That's why it is 6 plus 7, 13. Right. And C614, that is number of neutrons are 8. That's why it is 8 plus 6, that is 14. Right. So these two are the examples of isotopes. Okay, children, even though these isotopes all are having the same atoms and the same number of protons, So chemically they are all same. That means they have the similar chemical properties. But only sometimes the physical properties like density and melting point, those can be different. But chemically all are same. All are carbons, all are hydrogens. Understood? So these are the properties. Chemical properties of isotopes are identical. But physical properties such as density can differ. Okay? Have you understood, children? Right. Good. Now, this is the relative atomic mass. How are we going to calculate the relative atomic mass? Right? See, the average mass of an atom by taking the amount of each isotope present in an element. Now, in the previous slide, I have explained that each element can have different, same atoms with the different mass number. What do we call them? Isotopes, right? For example, if chlorine has several isotopes, like 2 or 3 isotopes, right? How are we going to find out the atomic mass? Now, previously mass number means always we denote them with the number, right? But here, if there are 2 or 3 isotopes, how are we going to say that what is the real mass number or atomic mass? Now, how do we calculate? Yes, we take the average, isn't it? Now, for example, if there are several numbers, when we say that what is the average of these numbers, what do? We add them and divide by the number of substances, isn't it? Right? So, here also there is a formula to find out the relative atomic mass of all the isotopes. So, with the example, let's see how we can calculate. See, example is there are 2 common isotopes of chlorine. Calculate the average relative atomic mass of chlorine atoms. Okay. One is chlorine 1735, in which protons are 17 but the neutrons are 18, right? What is its percentage abundance? 75, right? And chlorine is, another one is chlorine 1737, that is another isotope. So, then it is same number of protons but the neutrons are 20. Okay. How much does it exist? 25%. Okay. Percentage abundances can vary, right? It could be different. It doesn't matter. Only thing you have to focus is the mass number of these 2 isotopes and the percentage abundance, right? How much they are available. Always remember, when you add this percentage abundance, it should be equal to 100. Sometimes if it doesn't get equal to 100 also. So, always remember that total only you have to keep. Okay. So, let's calculate. Now, how do we calculate? In this way. Out of every 100 atoms, 75 are chlorine 35 and 25 are chlorine 37. Isn't it? Right. So, this is how you are going to calculate relative atomic mass. 75 chlorine 35 atoms. So, you have to multiply 75 by 35 and 25 by 37. And you have to add both of them and divided by, what is the total percentage here? 75 plus 25 is 100. So, divide by 100. So, what do you get now? You get, yes, that is the relative atomic mass of this chlorine, these 2 chlorine isotopes. Now, if anybody asks what is the relative atomic mass of chlorine? So, we have calculated this. Now, it is 35.5, right? Always remember, the relative atomic mass what we get should be almost or close to these values. See, this is 35 and 37. 35.5 is closer to these 2 values. Can you get like 55 or 71? No, then that is somewhere you have made a mistake, right? Always cross check when you are calculating. Understood, children? So, this is the relative atomic mass of the chlorine atom. Because it has 2 isotopes, now we know how to calculate. Okay? Right. So, that's the end of the lesson. So, let's look at the summary what we have learned so far. So atomic number, that is right, number of protons in the nucleus, and atomic mass, number of protons plus neutrons in the nucleus. And neutral atom means always the number of protons are equal to number of electrons. And what are isotopes? Isotopes means atoms with the same atomic number but different mass number, or the same number of protons but different numbers of neutrons. And what is relative atomic mass? The average mass of an atom by taking the amount of each isotope present in the element. Okay, children? Right. Here is another exercise. So you have to calculate the average relative atomic mass of neon. So here you have three isotopes, right? One is neon 20, other one is neon 21 and neon 22. So their percentage abundances also are given. You have to just calculate the relative atomic mass. And the second question is you have to find the symbols for these subatomic particles. So one is having 8 protons, 8 neutrons and 8 electrons. So you should know what that element is or the atom is. So you have to complete this with the suitable atomic symbol. Okay. And the third question is you have to answer the chapter questions on the textbook, that is page number 21. Right? Please answer all these questions. So that's the end of the presentation, children. Hope you have learnt every detail of the atomic structure and the isotopes and the relative atomic mass and the mass number and atomic number and all. Right? So thank you for listening and have a good day.